So this is question number 2 from the extension exercise. A cylinder inside a cone, and we are asked to find the maximum possible volume for the cylinder. So to start this activity, we're just going to redraw part of what's going on. And you can see what we have here is this is radius r for the cylinder, height of the cylinder. Then we have the height of the cone and the radius of the cone, both in capital R and capital H. So we're going to use the property of similar triangles here, and being that if I can use this triangle and this one, then they are similar triangles. So we have the height of the smaller triangles, and then this distance here is actually r minus little r. So the relationship then is h over r is equal to h over r minus little r. And that's kind of useful. We'll just hang on to that. Now the volume of a cylinder is pi r squared h. And you can see now that I've, in this equation here, I've got an h, and we will we'll make h a subject, and that becomes h times r minus little r over r. Okay, so now replacing all of this, so the v now becomes pi r squared times h, which is h times r minus r all over capital R. All right, so we've got an equation there for the volume, and we'll simplify that a little bit. So let's multiply all that out. So I get pi h capital R squared minus pi h, and that's r cubed, and that's all over r. So we can go ahead and differentiate that now. We'll differentiate with respect to r, and that gives me 2 pi h r minus 3 pi h r squared, and all of that over r. So last job now is to set that equal to 0. So if all of that's equal to 0, then we can kind of this r here, whoops, I shouldn't have done that, wrong thing. This r here is actually going to disappear eventually, because if we multiply it through by r, then that goes, and then just rearranging the left of the equation, so 2h r minus 3 pi h r squared is equal to each other. So a bit of cancelling out can occur. So you can see the h's cancel, the pi's cancel, one of the r's is cancelled out. So what we're left with is 2r is equal to 3r, and then r is equal to 2r over 3. So we've got that far. That's wonderful. So next thing to do then is to work out what the height is, because we're asked to find what is the dimensions, the radius and the height of the cylinder, if it's to have a maximum possible volume. So I've got an equation for h, so I'll copy that and bring that down here. So I've dragged an extra r in there, get rid of that. So we can use that h here and substitute r into it. So h is equal to h capital R minus, now the r there, go away, what's going on there? Thank you. So the r there is equal to 2r over 3, all of that over r. So r minus 2r is actually h is 1/3 r over r. The r is cancelled, and we're left with h over 3. So the height is h over 3, and the radius is exactly that. And that's wonderful. We're finished.